Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by the Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to this course titled Maritime Structures, Types, Construction, Pre-Service Analysis and Design. This is a course operated under Swayam Prabha and offered by Department of Maritime Engineering at IIT Gandhinagar. Friends, this is a very different and interesting course of very high professional importance. The title of the course, as you see here, Maritime Structures, talking about different types, construction, pre-service analysis and design, will help you to give an overview of many different aspects of maritime structures in one single course. This is a professional course which will also improve your employability with different maritime sectors in the country as well as in the international perspective. Let us see what will be the course content we will discuss in this course, what we otherwise call as course objectives. Friends, this course will make you understand the following in detail. You will come to understand different types of maritime structures. You will also learn materials used for constructing these kind of structures in detail, the choice of material, material classification, properties and the engineering perspectives. Friends, there is a very important aspect to this course where different types of maritime structures offer different load transfer mechanisms. The load transfer mechanism is geometric dependent, and therefore, as an engineer, it is very important to understand this mechanism if you want to design the system properly. And all we know that the maritime sector has now launched various innovation in terms of its construction, operation and functionality. So, innovation in geometric forms is an imperative part of this particular type of structures, which we will discuss in detail. Professor, I am Chandrasekaran from IIT Gandhinagar, and this course will also jointly handled by Professor Gaurav of Department of Civil Engineering. We are available for your contact at any moment in the email address given below in the screen. We will also help you for all your questions. In turn, you answer them in detail as we meet with them. This course will also discuss about construction methods, pre-service analysis and design. One may ask a question, what do we understand by pre-service analysis? Analysis and design we all know, but what is pre-service? Pre-service is a very important aspect of checking the viability of constructing a new geometric form under given environmental conditions. For example, the structural system is very huge in size and is massive. Therefore, the analysis also deals with kind of installation processes which makes the system safe as well as deployable in the specific water depth in ocean. The course will also deal with the basics and application examples of design. We will focus more intensively on fixed type of marine structures as far as design is concerned, but as far as geometric forms and other aspects are concerned, we will talk about all types of marine structures. So, friends, this course will also have detailed understanding about conventional loads, different forms of loads acting on maritime structures, construction methods which is related to fixed maritime structures. In addition, for the interesting application of design, we will also touch upon certain special topics such as curved beams, advanced design such as lateral, torsional buckling in steel, wind and wave energy harvest systems, which is dealing towards the blue economy of the country. We will also talk about design for LNG platforms and regasification platforms, which are very upcoming designs in maritime sector in the country. So, this course will help you understand in detail the methods and the issues related to these aspects. So, let us quickly look at what are the prerequisites of this course. Very interestingly, friends, this course has no prerequisite. All will be welcome to understand this course and register for this course, except that resolve never to quit, never to give up, no matter what the situation is. So, friends, this course is a multidisciplinary course open to various systems of engineering and discipline, like we see them in the next slide. Let us see what is the course plan for this particular course on maritime structures. The maritime structures course will run in 4 modules. Each module will have about 12 lectures. Therefore, the total lectures will be approximately about 48 lectures distributed in different weeks of 12 in number. All modules will be operated and recorded and displayed in the same sequence to understand the course completely in a follow up manner. Each module is designed also with few tutorial sheets. We will also give you the solution for the tutorials, so it will help you to do and improve self learning of this course and make a successful attempt to learn and understand all modules of this course. We are also suggesting some additional reading material at the end of each module. So, one can also go through this additional material for better learning and understanding of this course. Having understood the course plan, let us see what are available in different modules. Friends, you can also take this course module wise if you are interested in certain set of topics, but I would advocate you to learn this course in total of all the 4 modules. In module 1, we will talk about types of maritime structures, load transfer mechanisms, then we deal with different types in detail: fixed type, compliant type, floating type, form dominant design approach useful for these types of platforms, and then we will also talk about the most innovative and recent form of structures which we call as new generation platforms. So, we will discuss these details in the first module. The second module will focus on engineering materials used for construction of maritime structures. This module will also help you to understand design methods of steel structures, because steel is one of the common and most preferred material for maritime structures. Of course, port and harbour structures are also constructed by concrete. So, we will also touch upon design methods related to reinforced concrete structures as applicable to port and harbour structures. There we will talk about design methods applicable to various kinds of loads, axial, bending and their combination. We will also touch upon very interesting aspect of design of curved beams. One can ask a question, what is the use of learning a curved beam? For example, friends, you take a vessel and the vessel is actually sailing, and the vessel reaches the port. You got to embark the cargo on the vessel. So, you need to have a crane which is fixed on the vessel. The crane actually has a hook. Unless otherwise you know what is the capacity by which this hook is selected, you cannot use this particular crane for unloading or loading the cargo. So, crane hooks come under the concept of curved beams. Friends, curved beams are essentially beams which are curved in elevation, not in plan. Plan curved beams are a part of classical civil structural engineering, but here elevation wise curved beams are very special application related to crane hooks, which are essentially important for a maritime engineer to choose. So, we will talk about curved beams design in detail, where we will talk about curved beams with large initial curvature and with small initial curvature, large and small. Having said this, we will go to module 3, where more intensive design topics will be discussed, starting with lateral torsional buckling. Friends, believe me, it is very important for you to learn that many special structures of large span have failed in lateral torsional buckling. There has been issues on bridges, industrial structures, silos, etc., where the structural members have failed under LTB. LTB is a very important segment of design. In steel structures, which we will deal in this course in detail. Of course, this course will give you a clear understanding about various environmental loads starting from wave loads, wind loads, ice loads, earthquake loads, fire loads, and then we will deal with fluid structure interaction. Once we learn all these loads, then we will start understanding the design of tubular sections using API and DNV codes. We will do design examples and we will also use MATLAB programming for solving these kinds of problems using DNV and API codes. Having learned this, we will move to module 4, where we touch upon fundamentals of structural dynamics, because you know wave loads, wind loads, etc., they are function of time, they are dynamic in nature. Since they are dynamic in nature, we also discuss about introduction to structural dynamics. We will touch upon single degree and multiple degrees of freedom. We will also discuss about various damping modes, and most importantly, for a given existing structure, we will also talk about response control methods. There are various methods by which the response on a superstructure, deck of a platform, deck of a vessel or a ship, etc., can be controlled. So, we will talk about these control mechanisms in detail. So, these are the 4 modules by which this entire course content will be covered. Module 1 about introduction and types, module 2 about material and curved beams, module 3 about different design aspects of various members under different kinds of loads, and module 4 about introduction to structural dynamics. Having said this, let us talk about some important references which will be helpful for you to learn and read this course in my absence. Of course, the instructors of this course, myself, Professor Srinivasan Chandrasekaran and Professor Srinivasan of IIT Gandhinagar, are available to you round the clock 24/7 for answering your queries when you are registering for this course. However, if you want to learn additional information, you can refer to these important references: Computed Analysis by CRC, authored by me; Fundamentals of Offshore Engineering, authored by me with other authors in abroad as well as in India; myself and Gaurav authored a book on fire resistant design of maritime structures; myself and other professors internationally renowned have authored a book on design aids of offshore platforms, and so on. The content of these references will be separately available to you as a PDF file, and you can also access IIT Gandhinagar intranet library to access these books as an e-book in a soft format. If you register for this course, you will be given a license to access these books. You can also read them from the intranet facility of IIT Gandhinagar Central Library. Having said this, let us move on to why maritime engineering is important. Let me ask this question: why maritime engineering is important? Okay, very interesting, friends. Gujarat, being in India's longest coastline and also having major ports in operation such as Kandla and Mundra, Gujarat is one of the leading maritime gateway for India. So, IIT Gandhinagar, located in Gujarat, taking a lead in maritime education for the country. Gujarat is also a hub of trade, logistics and shipbuilding in the near future. The Department of Maritime Engineering at IIT Gandhinagar is dedicated to provide research expertise and skilled workforce needed to develop and support this national initiative like Sagarmala and Blue Economy. So, Sagarmala and Blue Economy, friends, as you know, they are important mission of Government of India. So, to improve the capacity building and to also provide technical support to strengthen these missions, we need maritime engineering as a full-time program. Further, it will also help advance in sustainable maritime technologies, coastal infrastructure and maritime security. These are all additional benefits what we learn as we know from this course. IIT Gandhinagar will be a leading center for maritime education in the country, innovating and fostering industry academia collaboration with global partners. Friends, you will see this program of maritime engineering in IIT Gandhinagar will also have international faculty who will give you very nice exposure of maritime sector in the entire world. Having said this, let us ask a question more in detail: why maritime engineering is important in education perspective. The need for maritime ecosystem built on robust connectivity, simplified processes and ease of doing business is on the growing demand. With the recent perspective of national budget, with Government of India focusing on blue economy, you will notice that there is a very high demand coming to maritime sector. Beyond operational efficiency, development of commercial ports capable of shipbuilding activities with a special focus on ship design and port planning is an integral part of innovative maritime industry. So, this course will help you to contribute to strengthening this infrastructure and industry likelihood linkages in order to provide future maritime economy, strengthening them for Government of India. So, now we learned what is the necessity of this course, what are the different modules of the course content, why maritime engineering is important to learn, and what are the references we have on this sector to this course, and who are all the instructors who will be dealing with this course, and where this course can be learned in physical mode. So, I emphasize again, friends, maritime engineering is a very important and interesting multidisciplinary department with IIT Gandhinagar, initiated by Government of India to strengthen the blue economy of this nation. So, please join us in understanding the course content further by registering for this course under SwayamPrabha. It is important to note that maritime education must be realigned with global industry standards. As of now, marine engineering, offshore engineering, ocean engineering, naval architecture are studied in segmental part in different institutes in this country. Maritime engineering will be a united program which will include all disciplines in one shot. So, if you join this program and learn these courses, you will be called as a maritime engineer who will have expertise in maritime education as well as global industry standards to meet with different disciplines. For example, the disciplines like mechanical, electrical will help to continue to contribute the sector for developing professional skills in emerging technologies. AI integrated ship design, AI integrated port management has become a very common request in the maritime industry in the recent past. This will include digitalization, artificial intelligence, autonomous vessels and green shipping practices. So, this course will cover contents related to this. This course, in sense, maritime structures will talk only about the structural systems, but in other additional courses you will find all these applications also being taught at IIT Gandhinagar. Therefore, this course is a part of a dynamic curriculum, reforming greater emphasis on multidisciplinary learning and strong integration of practical exposure. Maritime industry, friends, is undergoing a significant transformation driven by technology, digitalization, regulations, and therefore it requires lot of skilled workforce with technical and soft skills to promote this particular sector. So, this course will definitely give you a good employment opportunity and make you future ready for employment in maritime sector. So, friends, so far we have discussed the course content, the necessity, the benefit of doing this course. Okay. If you have any questions, please post them to our email ID. We will be happy to answer further and interact with you in detail. Now, let us go to one important aspect of this particular lecture, which is offshore structures, where we talk about types, construction aspects and structural action. Maritime structures are of multidisciplinary interest. They attract professionals from civil, structural, mechanical, electrical, electronics, safety, materials, ocean, offshore engineering and naval architecture. Friends, see, such a huge multidisciplinary you will never find in any program at all. Maritime engineering is a colloquium of different engineering disciplines coming under one roof. Maritime structures are deployed for various functions. Coastal protection, which is very important, India being a peninsular country surrounded by water on all the three sides. Friends, there is another interesting point I want to discuss here. India is the only country where a ocean is named after this country. We have Indian Ocean. There is no other country in the world where the sea is named after the country. So, we are very special environmentally and ecologically. God has blessed us by a ocean surrounding us. Being a peninsular country, our coast is very important to get protected. Our naval defense is working very hard in doing that. Maritime sector is a good contributor to coastal protection and naval defense. In addition to that, we are also looking for fossil fuels, oil and gas exploration. You must have seen the recent innovations made by our Honorable Prime Minister towards making India self-sustainable in oil and gas exploration. Furthermore, 2050, India should lead shipbuilding and docking in maritime transport. So, looking into all these future aspects, you will notice that maritime structures is playing role in almost all sectors of national economy. Various structural systems that are deployed for maritime structures can vary with shallow water, medium water, deep water and ultra deep water. So, one may ask me a question, how shallow, medium, deep and ultra deep varies with numbers. Let us look at this number. If I say shallow water, medium, deep and ultra deep, if you only talk about water depth for as a thumb rule, which we indicate as small d, whereas capital D is used for diameter. So, shallow waters is less than about 150 meters. Medium is between 150 to 250 meters. Sometimes they are extended till 400 meters. Beyond 400 and up to 1000, we call them as deep water, and beyond 1200 meters, we call them as ultra deep waters. Friends, to give you an idea, what is this we are talking about here? We are talking about a structure which is used is the water level. So, I am talking about this depth, this may seabed. This may water level. So, we call this as D. So, this D is what I am referring here. So, the depth of water where the structures are commissioned vary with these depths. Remember, they are in meters, okay? They are not in feet. So, 1200 meters. For example, to give an idea, one story of the building is about 3 meters. So, we are talking about 150 meter, which is about 50-story building. So, these structures are very huge, friends. They are very massive. They are very strong and safe, and they are built with steel or with concrete structures. So, these structures are commissioned at various water depths: shallow, medium, deep water and ultra deep waters. Of course, as you understand now, the structural system meant for these water depths cannot be same. So, they have a geometric configuration varying with depth. So, let us come to this argument again. So, when we talk about geometric configuration, they are hugely different. For example, for shallow and medium, people can go with fixed type of structures. When we move to deep and ultra deep, people go for floating structures. Friends, I am talking about a structural system which is completely floating in sea. So, these structures can also be used for oil and gas exploration, naval defense, drilling purposes, etc. They are not necessarily ships, they are structures. Approximate size can be 100 meters by 100 meters. For example, you live in a room of 3 meter by 3 meter, I am talking about 30 times larger than your house. Such a huge system I am talking about. So, system is very massive, very large, very special and useful for various applications in maritime industry. So, this is a very non-conventional, new, unique type of structural systems which you have never heard of in civil engineering platform at all. So, it is rather fascinating to know these structural systems deployed in waters are not similar in nature. So, therefore, the loads acting on the structures make them completely different. The structural actions are very widely different due to their compliancy and geometric properties. Having said this, let us talk about different types of offshore structures very quickly to be very specific. So, from maritime structures, I am moving to offshore structures. Let us see what is offshore structure. Offshore is structures constructed offshore. That is, they are not on the shore, they are away from the shore into sea. To be very specific, let us make a figure. This is my coastal line, this is my structural system. I am drawing a plan, structural system, another structural system and so on. So, they are away from the coast, okay friends, they are away from the coast. So, since they are away from the coast, we call them as offshore. The one which is built on the coastal line, okay, these are called as port structures, harbors or coastal structures. The one which is away from the coast is called offshore structures. Put together are called maritime structures. So, maritime structure is a combination of different kinds of structural systems as you see here. So, let us see quickly what are the types of offshore structures. Friends, offshore structures are types of maritime structures constructed offshore. We already said the difference between offshore and onshore. So, let us now look at different types of offshore structures which are dominant part of maritime structures. Look at this figure and pay attention to the water depth. So, the figure what you see here, there is a profile which I am now drawing. Let me do it again. There is a profile I am drawing which is actually the seabed. Okay. You know, seabed is not horizontal, it is always depending upon the terrain and the depth. So, if this is the seabed, the depth at which, and this becomes the water level, what we call a still water level or surface of water in sea. So, now this becomes my water depth at this structure, this becomes my water depth for this structure, this becomes my water depth for this structure and so on. So, water depth of installation varies with different types of structures. Okay, that is the first observation what we make from this figure. Let us see the second one. A fixed structure is commissioned at a lesser water depth compared to a compliant structure. So, fixed type is one of the structures. Second is the compliant tower. Third is tension leg platform, abbreviated as TLP. The water depth for TLP is more than the compliant structure. In this figure also you will see various types of substructures which are also constructed and commissioned at different water depths. Fixed structure, or we call as jacket structure, compliant tower, floating production systems, we call this as FPS, then tension leg platform, then spar, single point anchor reservoir. So, you see different types of structures like fixed type, floating type, TLP, spar or commission for different water depths. So, one can see from this figure easily, as the water depth increases, okay, we go for deeper structures than shallow structures. So, fixed jacket structures are meant for shallow waters, TLPs and spar are meant for deep waters. Intermittently, can also have these kind of structures for medium waters. So, we already saw the different types of water depths like medium, shallow, medium and deep. We will come to ultra deep separately later, because this will talk about innovative structures. So, shallow, medium, deep, shallow, medium, deep, shallow, medium, deep. So, one can say the structures are grouped not based only on the geometry, but also on the water depth. Pay attention to the superstructure. The one which is below water is called substructure, the one which is above water is called superstructure. Okay? The one below water is called substructure, the one above water is called superstructure. Pay attention to the superstructure. Like, I will just open this for you in detail. You can see that most of the element which is supporting the load is a truss form. It is essentially steel. Okay? The one which is used in the tall is called the drilling derrick. This is we call as a flare boom. What is a flare boom? When an offshore platform is commissioned, for example, let us say an offshore platform is commissioned, so this becomes my leg and this is my water depth, this is my seabed, this is my water depth now, this is my sea water level. So, I construct a structural system on the top here. The cantilever boom, so this will be connected to my offshore drilling facility. When the oil or gas is released from the well, the gas will exit with a high pressure and high temperature. So, if you do not allow this gas to escape, this will start spreading all over the surface and will cause accidents to this. So, this gas is allowed to escape through a boom. We call this as a flare boom. You know, flare refers to heat or fire. So, when this flare boom is operating like this red color, see here, it means the gas is functional. It means the offshore platform is operating. So, this is what they call as a sea torch. In layman's language, they call this a sea torch. Sea torch is an indicator that the platform is in functional position. So, this is a flare boom. I will rub this because it is not required to be understood at this moment. We will talk about this detail. So, these are drilling derricks, there is a flare boom, and this is nothing but a simple crane. Okay. The one what you see here, the smaller ones, okay, the smaller ones. These are all living quarters. People live here. Those who work on the platform, they live here. Okay. Now, you can ask me an approximate size of this platform for our understanding. The length of the platform is about 100 meters. The breadth of the platform is 100 meters. Each tire, each is about 10 meters, and this derrick is about 75 meters. So, from the sea, if you look at the top of this will be more than 110 meters, friends. So, you will imagine that a 40-story building floating on sea. There is another 40-story below. Okay. So, it is a 80-story building. It's a massive structure. Okay. So, this kind of structural system needs lot of understanding in terms of wave loads, wind loads, ice and earthquake loads to design them. So, this course will talk about the design of structural elements of these kind of structures in detail. So, we have understood that water depth demands different kinds of structural geometry. The geometry of the system is not same for all water depths. You can see here, as you move deeper and deeper, this part of the structural system is vanished. From here you move deeper, it has become thinner. You further move deeper, this is completely taken away by only wires. So, as you go deeper and deeper, the substructure becomes very simple, but there is no variation in the superstructure. Superstructure remains same, substructure remains different. This is what we call as form dominant part of the design. We will discuss this in detail in the lectures. So, what we learn from here is, as we go deeper and deeper, the structural form of the substructure varies significantly, whereas the superstructure almost remains similar. So, let us write down that conclusion here for our understanding. As we go deeper, the structural system of the substructure varies significantly, whereas the superstructure remains similar. There is a very important aspect we learnt from this. The second is, as you go deeper and deeper, the substructure becomes simple. We call this as floating structures. So, now we learned the difference in the design between a substructural system in shallow water and the one which is in deep water. So, this is for shallow water, this is for deep water. So, as you go deeper and deeper, you will notice that the substructures become very, very simple. As you go shallow waters, substructure becomes more complicated. However, for our learning exercise, we will also know how to design the substructure for shallow waters, how to design the superstructure for deep waters. Okay, that is what the focus of this course is. Having said this, let us see how do we classify the types of offshore structures. We already said offshore structures are those maritime structures constructed off the shore from the coast for various purposes. So, the first type is fixed type platform, second is compliant type platform, third is floating type, fourth is new generation. Friends, please pay attention to this spelling. It is compliant, it is not compliant. Okay, compliant means flexible. Compliant means flexible. So, fixed platform is bottom supported structure, whereas compliant platforms are completely flexible. So, from one stage we move to the other, from other stage we move to floating, from floating we further move to new generation. So, what are different platforms under these headings? Jacket platform, gravity based structures, jack-up rigs. These are called fixed platforms. Guide towers, articulated towers, tension-leg platforms are called compliant platforms. Compliant, please pay attention to the spelling. Drill ship, semi-submersible, FPSO, floating, production, storage, offloading. FPSO, spar, single, point, anchor, reservoir. Okay, these are very common terminologies used in maritime engineering. So, we have to learn the vocabulary as well as we learn this course. So, drill ship, semi-submerged, FPSOs and spar are referred to as floating platforms. Whereas, when you come to new generation platform, which are in existence only from 2010, about 15 years down the line, triceratop, buoyant leg structure, regasification platform, these are all used for various purposes like wind energy, wave energy, harvest systems. So, we talk about energy harvest systems also in this course. So, friends, offshore structures are of different types: fixed, compliant, floating, new generation. In fixed, we have jacket, GBS and jack-up rigs. In floating, we have guide tower, AT and TLP. In floating, we have drill ships, semi-submersibles, FPSO and spar. And in new generation, we have triceratops, BLS, BLSRP, which are all used for various applications in maritime sector. So, if you have any specific questions at this particular point of time, please post them to email and SwayamPrabha will address this 24/7 and all responses will be recorded and sent to you back with full assistance from the instructors. Myself, Professor Srinivasan Chandrasekaran and Professor Gaurav will join you in answering your questions whenever you raise any one of them. We will take another 5 more minutes to do this particular lecture. Stay with me for another 5 more minutes and learn the first lecture of this particular course. Let us look at these figures, which are shot in 1902 and 1919, about 100 years old. This is a typical structure I am talking about. There are many structures, not one. See here, there are many. There are many. But look at the substructure of this. Okay, look at the substructure. This is the water level, this is the bridge. Look at the substructure. Most of them are truss oriented. I can write down in here observations. Most of them are truss supported. They are essentially wood, because steel came later. Essentially wood. See here, essentially they are wood, wooden structures. They are fixed to the bottom. See here, they are piled, they are fixed to the bottom. So, fixed structures were used on shallow waters, and the first one what you see here is in Huntington Beach in California, which was constructed in 1902. Friends, offshore engineering and maritime engineering is a program or state of art of engineering which is 125 years old. It is not yesterday born engineering. We do not know this, that is a different story, but it is not a recent engineering. It has been in practice in USA for the past 125 years. So, the first one constructed in Huntington Beach in California. Now, you will see most of the beach sites in US as well as in European countries were all removed from these kind of structural systems, because they were earlier getting oil at shallow water depths. Now, oil is not available at water depth less than 1500 meters. So, you know that there are several drilling rigs deployed along the coast. Most of them were either built of steel or wood. The structural configuration is very simple, it is a truss element. Furthermore, these are otherwise called simply as drilling rigs. They are simply rigs. They were constructed all on the coast side. Now, for your idea, look at the proportion, look at the height of the structure, look at the height of the human being. So, proportion given to you to understand how these structures are much taller than the human. So, these are approximately about 75 to 100 meters, whereas this is about 1.5 to 1.8 meters, 5 to 6 feet. Okay. So, these structures are built along the coast. One can see there are various types of structures constructed, and US owns and constructed more than at least about 200 platforms, at least, since 1905. Same thing happened in Summerfield in California. This photograph was shot in California Summerfield offshore site, where drilling rigs were constructed sequentially all along the coast. Now, you will not find them, they are all completely removed, but this is a very old photograph. So, we understand this, that maritime engineering is about 125 years old engineering. It is not yesterday born engineering, friends. Okay. Having said this, let us also take one more view of the Venezuela in Caspian Sea, which is built here. This is a complete steel structure built in 1924, and the substructure is of course inside water, which is also very shallow. One can see the height of the structure, see the geometry, it is like a simple tower, is it not? It is a simple tower. What you see for electrical substations, similar towers, and this height will be approximately 75 to 100 meters. Okay. Broader base, narrow top, and centrally concentrated design. Okay. Broader base, narrow top, centrally concentrated design. That was the original idea people had in mind in offshore structures. Okay. So, definitely you will notice that this figure tells me how the offshore structures have been constructed along the coast. See here 1, 2, 3. Then once you drill oil from here, this oil has to be brought to the coast, either by roadway or a bridge or by a vessel. So, offloading or transporting oil from the offshore site is a big task. Okay. Transporting oil is a big task. So, people spend lot of money in transporting this oil from the offshore site to the coast. So, this was a big economical problem faced by many countries in the world, including USA, Europe, Australia, Canada, China, and of course India. So, friends, building the structures off coast or offshore will give an important problem of transporting this oil to the coast. So, we cannot construct these structures in the coast itself, because there is no oil available here. So, as you go deeper and deeper, as you go offshore away and away, you will find that transporting oil through bridges or vessel is impossible. It is going to cost you more. So, what is the solution people achieved to do that? So, this is a very interesting learning part from this course. So, because of paucity of space on drilling platforms, upstream activities like drilling and production etc., and downstream activities such as processing were carried out offshore and onshore. So, now let us see what is offshore and onshore. Offshore and onshore. Onshore is one which you do on the coast. Offshore is one which you do on the sea. You do it on coast, the cost is lesser. To do it offshore, the cost is very high. Okay. So, since oil is available offshore, oil and fossil fuels are very expensive. Since coal and thermal are available onshore, they are cheaper. That is why you see India is gradually moving from fossil fuel to wind energy. Okay, there are a lot of wind farms built all along the coast of India to generate power. So, maritime sector has been moving, advanced from offshore to onshore, and both of them we know it is maritime engineering. Okay, we already said that. Friends, let us look at the summary of this lecture and see what we have learned in this lecture quickly for our understanding. This lecture helped us to understand what are the contents of this course, what are the different modules of this course, why one should study maritime engineering, what is maritime engineering, what are the important references for self-learning. Then we learnt about different types of offshore structures, what is the difference between offshore and onshore, how economy is controlling the design, how water depth controls the design, what is the natural geometric form of these kind of structures. So, friends, we complete this lecture at this particular point. Whatever questions you have, please email to us and we will be able to answer these questions under SwayamPrabha 24/7. Thank you and have a good day. Namaste.